We will do an example of an improper integration in iterated integral format. So if you look at the integration on your screen, you will see the limits of x are finite. They are 0 and 5, whereas the limits of y is 0, but the upper limit is infinity. So the way we're going to solve this problem is bringing in a limit term. So we're going to rewrite this integration as limit n go to infinity. We'll keep the finite limits as they are, and in place of infinity we're going to put this new letter symbol, and then I get x squared over 1 plus y squared dy dx. Then as usual we are going to first integrate with respect to y, and we will get limit n go to infinity integration 0 to 5. Remember, when you are integrating with respect to y, x squared is a constant term, so it is going to stay outside, and I will get dy over 1 plus y squared. Remember, integration of dy over 1 plus y squared is arctangent of y, and the limits are 0 and n. Finally, we will integrate this result with respect to x. So I get limit n go to infinity integration 0 to 5 x squared. I'm going to go ahead and put the limiting values in for y. So arctangent of capital N minus arctangent of 0. And this I'm going to integrate with respect to x. So now we are going to slide this limit inside the integration, and we'll get integration 0 to 5 limit n go to infinity x squared arctangent of n and remember arctangent of 0 is 0, so I don't even care about that term. So this is what I get. Think about the graph of the tangent function. At negative pi over 2 and pi over 2, tangent has asymptote, and the graph looks like this. So tangent of theta goes to infinity as theta goes to pi over 2. That means arctangent of n as n goes to infinity will be equal to pi over 2. So we're going to use this in our integration, and the integration becomes integration 0 to 5. Instead of writing limit n go to infinity arctangent n, I'm simply going to write it pi over 2 dx. Since pi over 2 is a constant, I can take it outside and write it as pi over 2 times integration 0 to 5 x squared dx. So it becomes pi over 2 times x to the power 3 over 3, and the limits are 0 to 5. So when I put x equal to 5, I get 125, 5 to the power 3 is 125, pi over 6. If I put x equal to 0, I get 0, so I don't write that term, and hence the value of the integration is 125 pi over 6.